My name is Joshua. Today, we will share one of our product line, ICF 1180 and 1280 series. They are Profibus to fiber converters. Let's go back to the topic. In the course, I will share the product feature and function with you. After the course, we hope you will be able to know 3 key points: when to use the product, what is the product feature, and how to use fiber diagnosis function. This is the outline. The course is divided into 3 parts. We will start from product introduction. Then, we will focus on the product features. And the last one, we will recap on the points of the course. There are 2 kinds of Profibus to fiber converter, ICF 1180 and 1280s, which we will focus on these 2 products. But before starting, I know you have a question. What is the solution that the products provide and when to use it? Let me explain it with the following slides. There are 2 main purposes of the Profibus to optical fiber converters. One is to extend the distance, because the distance of the fiber is longer than Profibus cable. 45 km for single-mode fiber and 4 km for multiple fiber. The other is the feature of the fiber transmission. It is emerged from signal interfaces under magnetic environment. I give you an example. If customer asks you, I have a PLC is a Profibus master, and Profibus device is a slave. Originally, they are communicating with Profibus cable, but now we move to the Profibus master to the other side, where it's far from the Profibus slave. Could you provide me a solution? Sure, we can. We have ICF 1180 and 1280 series, which can meet your requirement. You can use a pair of converters, which can extend the distance through the fiber, and the maximum distance can extend up to 45 km with single-mode fiber. Here is a successful story for the long distance. It's a water management application. In central office, there is a Profibus PLC, and the PLC would like to control or get feedback from the devices, such as pumps, valves, and measurement instruments, which is a remote site. You can see there are converters, and the backbone is fiber cable. Besides, we know the benefit of fiber communication compared with copper is anti-electromagnetic interfaces. In industrial field, we usually face electromagnetic interfaces when communication. It could come from motors, transformer box, and so on. Let's look on the sketch map. In order to avoid from the noise, we will use the feature of fiber emerged from electromagnetic interfaces, and the fiber will be set up on the place where it's probably easy to influence. Above all are some examples of the implications. In the page, I'm talking about the product view of ICF 1180i. From top to bottom, there are dual powers input terminal block, relay, and D-switch. LED indicators can provide system status, and the fiber port can be multiple or single-mode ST connectors. A Profibus side is a DB9 female connector. The page is ICF 1280i product view. The main difference between 1180 and 1280 is the number of the fiber port. For 1280i, there are 2 fiber ports, and it can do redundant. It's the product specification. Fiber connect can be single or multi-mode with ST connector. Fiber distance depends on the categories. Single-mode fiber is up to 45 km and multi-mode fiber is up to 4 km. Both of the models have 2 kilovolt power isolation. We also have temperature model for wide range operating temperature. The only difference between them is that ICF 1280 has two fiber ports, due to the fact the other fiber port can be redundant. Let's move to the next topic, product features. It's the product features that we are going to discuss in the following slides. From top to bottom, that is remote fiber diagnosis feature, redundant remote for communication backup, but it's only for ICF 1280s. Auto baud rate detection, and the last one is Profibus failsafe. In most cases, optical fiber cables are often deployed for long-distance communication, and a fiber optical inspection pen is used by engineers to ensure proper communication quality of the fiber cable. The converters eliminate the need for the fiber optical inspection pen by providing a remote fiber diagnosis function that uses this switch to adjustment. And you only need to enable diagnosis function at one side to examine overall topology. There are two major functions provided by remote fiber diagnosis. The first one, determine which side, transmitter or receiver, is causing the problem on the converter. The second one, examine the fiber connections for the overall topology from any individual converters. We also provide two links. One is the demo video. The other one is the hands-on guide, which is the good material for practice. To enable the function, set this switch A to the on position on any ICF 1280I converter and see the ready LED status. A flashing green ready LED indicates that the fiber diagnosis has finished. The full LED indicates the location of the fiber connection abnormality. The P1 or P2 LED indicates which side, transmitter or receiver, is causing the problem. For P1 or P2 LED, flash red indicates fiber cable leaking to receiver is abnormal, and solid red means fiber cable linking to transmitter is abnormal. For LED, flash red is fiber abnormality occur in another segment. Solid red is fiber abnormality occur on this converter. The ICF 1280I series converters can connect Profibus devices in a redundant ring topology. Use the D switch to configure all of the ICF 1280I converters to redundant ring mode. When the Profibus master transmits a signal from one converter to the Profibus devices, the signal will travel to all the converters around the ring until it returns to the original converters and terminate. Due to the fact, the benefit will be zero discovery time. The converters simply convert the signal back and forth between Profibus and fiber at baud rate between 9.6 kilobit per second to 12 megabit per second. Engineers don't need to know the baud rate of the connected Profibus devices. The converters can automatically detect the baud rate of the Profibus device and apply this baud rate directly. This is an extremely convenient feature. If necessary, baud rates can be set to a fixed value via dip switches to shorten the baud rate detection period when the system initialized. Profibus failsafe function. In industrial field, electrical noise may be generated when a Profibus device malfunctions or the serial interface fails, result in bus failure. Traditional media converters transmit noise signal through the fiber wire to the other converters. This not only disrupts data communication between the two buses, but will also bring communication across the entire system to the host. When this occurs, the engineer will not be able to easily locate the failure device because the entire Profibus network is down. To avoid the situation, the product has a mechanism to detect and recognize noise signals. If the bus failure on one side, the noise signal will not propagate through the ICF converters and affect additional bus segments. In addition, the converters will also trigger an alarm to provide the location of the failure to the field engineer. This is my last line. Let me just recap on the points of the course. The first one, ICF Profibus to fiber converters is mainly used to extend distance through fiber or emulate the noise. The second one, the product features. There are fiber diagnosis function, which can examine the fiber connection for the overall topology. Redundant remote, that is for communication backup. Auto baud rate detection can automatically detect the baud rate of the Profibus device and apply this baud rate directly. And the Profibus failsafe function will avoid from transmission noise. Thanks for your listening, and don't forget to take the quiz to know how much you have learned.